everybody, welcome back boys and girls. It's your main math man, Mr. Shank, coming to you live from Walker Grant Middle School. And in this video, we're going to be talking about some cylinders and how to find that surface area of a cylinder and the volume of a surface area. So to start us off, as always, going to do a little bit of quick math. So we're going to do 2 times 3.14, and we have 3.14 times 2, and then we have 2 squared, which is 4. So we're going to have 25.12, and we have 2 times 2 is 4, times 5 is 20, and then 20 times, let's do 20 times 3.14 is 62.8. Add those two together, 62.8 plus 25.12, grand total of 87.92. Moving on. 2 times 3 squared. 3 squared is 9, so we can say 9. 2 times that is 18, so we can do 18 times that 3.14 is that 56.52 plus. Then we do 2 times 3 is 6. 6 times 4 is 48, so we can do 48 times 3.14 is that 150.72. Add those two together very carefully, driving this calculated car considerably well. So I'm going to have 207.24. Moving on, I have 4 squared, which is 4 squared, 16 times 5 times 3.14. Starting to notice a little pattern here. We're still using that 3.14 pretty often here. So then we have 5 squared, which is 25, times 6, which is 150, and we have times that 3.14, and so we're going to have a total of 471. You know what? I want to double check my answer because I like being correct, and it is. All right. A little bit of warm up for our quick math. So now maybe think, why am I using that value? Well, let's find out. So some key ideas with this, we're going to be talking about on the front, we're going to be talking about, let's say front is going to be surface area. So that means this, we're going to say the surface area of a cylinder is the sum of the areas of the bases, and the lateral face. You can think of the bases as the top and the bottom of a can, and then you could say the lateral surface, or that lateral face, is going to be that label of the can. So again, it's kind of pictured here. Notice how it's in blue. We're going to say that that is going to be that lateral face, where again you have the bases on the top and on the bottom. So again, make sure that you're able to see either the 3D picture or the net. So now, when we're talking about the surface area of a cylinder, we're going to use this formula shown below. So we're going to say the surface area of a cylinder is going to be 2 times pi times the radius squared. And so that's going to be the area of the bases. And if you notice, why do we have that? Well, why is there 2 of in front? Well, we know that we have 2 of these circles, so that's our 2 bases, and the area of one of these circles is going to be, so let me say the area of this circle is going to be pi r squared. Then we say we add the area of the bases to the area of the lateral face. So we're going to say area of lateral surface. We can say surface. All right. So then again, make sure you're seeing what these symbols and letters stand for. So we're going to say again, as a reminder, that's that Greek letter pi. Always let that just be very simply 3.14, and then we can say r is going to be our radius. R is the radius of that circle, and h is the height. So the height of the cylinder. So always use this formula for that surface area of a cylinder. So now in that first example, again, same steps as always. We're gonna say, all right, wanna make sure we can label. Well, what do we need to label? We're gonna say that, hey, we're gonna say this is gonna be R and this is gonna be H. So we're gonna say our radius for this one is gonna be 4 and our height for this cylinder is going to be 3. Make sure we can write that formula. We can say this, we're gonna say surface area is equal to 2 times the pi times the radius squared plus 2 times pi times the radius times the height. Plug in your values for your variables, so we're gonna substitute. We're gonna say surface area is equal to, well, let's have 2 times 3.14 times that radius squared. Again, be careful and make sure that you use these parentheses carefully. So I'm gonna say my radius, which is 4, and I need to have that parentheses, I need to have that exponent in there because otherwise it might mess up my answer. So now I can say, all right, my lateral face is going to be 2 times, let's have 2 times pi, so 3.14, and the radius, which is 4, times the height, which is 3. Make sure you're evaluating these values carefully. So I'm going to simplify as follows. I know from before we had 4 times 4 is 16, and then we had 16 times 2 is 32, and so I can say, all right, let me do 32 times 3.4 is going to be 140.48, and I'm going to say plus, let's do it like this, 2 times 4 is 8, 8 times 3 is 24, and so I can have 24 times that 3.4. 75.36. Again, make sure you add those two together. So we're going to say the grand total of the surface area is going to be 75.36 plus 100.48. So we're going to have 175.84. Make sure you have your units. And so we're going to say millimeters. Let's double check. Millimeters. So we'll talk about surface area. That's to the 2nd power. You can always make sure you have those units. Raise to the 2nd power for surface area. And on that second part, maybe pause this video, give yourself a minute to breathe, read through it, and try it out for yourself. So for your turn, it says find the surface area of a cylinder with a radius of 3 inches and a height of 4 inches. So very obviously we're looking for, let me be very careful, we have the surface area, and we're saying, all right, the radius is 3 and the height is 4. A lot of people are gonna be like, hey, it's that answer right there, but if you actually notice, we have these flipped around. So we're gonna say the radius is now 3 and the height is 4. Make a prediction. Do you think, will it be the same answer or not? Let's find out. So again, same kind of formula. We're gonna say surface area. Or if you want to, you can also draw the picture. I like to draw very poor pictures because that is not my skill, but at least you can try for yourself. That way it is easier to visualize. So I'm saying the radius of that circle, and here is going to be 3. So we're going to say the radius is 3 and the height of this cylinder is going to be 4. So now again I have the surface area is equal to 2 times pi times the radius squared plus 2 times pi times the radius times the height. Substitute in your values for your variables, and so we're going to say surface area is going to be 2 times that 3.14. We have our radius squared. Make sure that square is in parentheses, so we're going to say 3 squared. And then we have the rest of our formula. So we're going to say 2 times that 3.14 times that radius, which is 3, and our height, which is 4. So now, again, make sure you're simplifying carefully. We can say 3 times 3 is 9, very good, times 2 is 18. So let's do it very simply. We're going to say 18 times that 3.14 is that 56.52. Then we can say 2 times 3 is 6, and 6 times 4 is 24. Very good. So we're going to say 24 times that 3.14 is that 75.36. Make sure you can add those two together to get that grand total for your surface area. We're going to say 75.36 plus that 56.52. And yes, you guessed it, it is not going to be the same answer. So we're going to say 131.88, but make sure you have those units, which it says inches, so it's a completely different answer to begin with. On the back, we're now going to be talking about some volume. So we're going to say on the back, we're saying volume, and when I talk about volume, I'm not talking about the pitch or tone of something, I'm talking about how much you can fill with it. So we're going to say this, we're going to say the volume. We're going to say the volume of a cylinder is, we're going to say the product. So again, make sure you use that word carefully. When you say product, you're talking about multiplying at least two things together. So we're going to say the product of the, let's say the area of the base. Let's say the area of the base and the height of that cylinder. And that makes sense. If you see the picture drawn out, you're saying, okay, I'm going to take that disc or that circle, I'm going to multiply it for each time we have that height. So again, you can kind of think of stacking quarters on top of each other. You'd be able to say, okay, how tall is that in total? And that would be your volume for that. And so we're going to say the volume of a rectangular prism is found by using that formula where it says volume is equal to pi times the radius squared times h. And so we're going to say pi is going to be about 3.14. We're going to say that radius is r, just like before, and h is that height. Make sure you're still seeing, again, we have in that red part is our area of the base, and that height h is there by itself. So now in that first example, just like always, be able to make sure you can follow these steps. And so we're going to say we want to label this first. I'm going to say our radius r is going to be 3 meters, and our height h is going to be 6 meters. Be able to plug those values in for your variables. So we're going to say, all right, formula first, we have v is equal to pi times the radius squared times h. So we're going to say volume is equal to 3.14 times that radius squared, so have that radius of 3 in parentheses squared. Then we have times h, which is 6. Multiply those variables, excuse me, those values carefully. So we're going to say 3 times 3 is 9, so times 6 is 54, times that 3.14 is what we are looking for. So we're going to say 169.56. Make sure you have those units. However, when we're talking about volume, we're talking about cubic units. So we're going to say to the third power. So our volume for this is going to be meters cubed. So now for your turn, again, same kind of setup. Make sure you can pause the video for yourself, read through it carefully, and then identify what you're looking for. So on where it says your turn, it says if a jar of salsa is 4 centimeters wide and 10 centimeters tall, then how much salsa can it hold? Be very careful, because when it says 4 centimeters wide, it's talking about that entire length across. So that's not going to be our radius. This is actually our diameter. So if you remember carefully, when you're thinking, actually what I can do is I can draw it kind of over here. I can say that, hey, when I have that jar of salsa, the whole way across is going to be 4. What we need is half of that, because half of the diameter is the radius, and so we're going to say the radius for this one is going to be 2. Again, that is where the common mistake is made. However, the height is just going to be 10, so we're going to say h is going to be 10. Still using that same formula, we have v is equal to pi times the radius squared times h. Plug in those values for your variables. So we're going to say volume is equal to 3.14 times the radius squared, which is going to be 2 raised to the second power. Then we have times h, which is 10. simplify very carefully. We have 2 times itself is going to be 4. 4 times 10 is 40, and so I'm going to say 40 times that 3.14 is going to be that volume. So we're going to say 100. Let's actually have it like this. We're going to say the volume is going to be 125.6. We're going to say centimeters cubed. That is a decent amount of salsa that can fit in that chart. So now lastly, putting those combined efforts together, you can think for your final boss battle, what can we do? Well, it says you're tasked with painting the truck's tank and also filling it with gas, so you're doing 2 jobs at once. It gives you the 2 dimensions you need to be able to solve it carefully. Maybe try this out for yourself. What I suggest you do is break it apart. First find either surface area, and then you can find your volume. So what I'm going to do is this. I'm going to say, well, I know I need to label it. It already has our radius as 4, and so that means the height, our height is going to be 50. Again, when you go to do your surface area formula, let's double check. What does that look like? Well, it says that it's 2 times pi times radius squared plus 2 times pi times radius times height. Let's see if we can remember that. 2 times pi times the radius squared plus 2 times pi times the radius times the height. Excellent. Make sure you can plug in those values for those variables. And so we're going to say, all right, we have surface area is equal to, we have 2 times 3.14. We have the radius, which is 4. Make sure that exponent is inside the parentheses. And then we can say plus, we have 2 times that 3 point, you know what? I'm going to actually write it underneath of it just so I can save some space here. Just make sure you have that plus sign so you know what you're doing. All right, so I have 2 times that 3.14. We have a radius, which is 4, and our height, which is 50. Again, anytime you see parentheses, make sure you multiply. So we're gonna follow along with this. We're gonna say 4 times itself is 16. 16 times 2 is 32. And now we can say, all right, we're gonna do 32 times that 3.14 is gonna be 100. And so let's do it like this. Let's say surface area is equal to 100.48 plus, and let's have the rest of it. 2 times 4 is 8. Let's do it 8 times 50, which I believe is going to be 400. 8 times 50, you better believe it. And we do times that 3.14. So it's going to be all together 1,256. Be sure to add them together because we're talking about combining those surface areas. And so we say add those 2 together to get a total of 1,356.48. And we're saying that's going to be feet to the 2nd power since we're talking about surface area. So that's how much surface area you'd have to cover it with paint. Again, we said that we're trying to paint the outside and fill it with gas, and so we need to also make sure we find the volume. So we're going to say volume is still going to use that pi times the radius squared times h. Make sure you're still using that same exact value. So I'm going to say our volume is going to be 3.14 times the radius squared, which is 4 squared in parentheses, and then we have h, which is 50. So we're going to have, even though it's the same variables or dimensions, it's going to give you a different value. Again, very rarely is your surface area going to be equal to your volume, especially when the units are completely different. So what do we say? Well, we're going to say 4 squared is 16 times 50 is going to be 800. We're going to say 800 times that 3.14. It is a grand total of 2,512. And we're going to say feet cubed since we have volume. So that is a decent amount of gas. Again, if you're thinking of a cubic foot, just put 3 rulers together to get a 3-dimensional shape. And you're gonna say, well, I have 2,500 of those. It's a decent amount of gas. Be sure to ask any questions at any point in time, and as always, super slam that subscribe button.